All right, now that we've got a pretty good grasp on concentration gradients, what we're going to do is we're going to walk through different mechanisms of molecular movement. So think about it this way. Each of these videos that we're getting ready to cover are different strategies for importing and exporting materials. The different strategies are going to help us move different kinds of materials in and out of the cell, as well as moving the materials different directions relative to that gradient. We're going to start with diffusion first. What diffusion is moving is specifically the solutes. So remember that solutions are comprised of two components, the solutes and the solvent. Okay. The solutes have been drawn into the solution by the solvent. So diffusion is specifically charged with moving the solutes, and the direction that it's moving them is from high concentration to low concentration. If you recall, we have another word for this as well. This can be described as going down the gradient. Anytime materials are moving down the gradient, it's going to do that naturally. So you do not need to add energy. But I want to kind of emphasize this. So you don't need to input energy. It doesn't mean that energy isn't being expended. Anytime molecules are moving, energy needs to be expended because movement requires energy. So if molecules are moving down their gradient, then energy still has to be spent. It's just that we don't have to input extra energy for that to happen. Why? Because we are using energy that's already there. Remember how we said that gradients have potential energy that is stored? When you're moving down the gradient, you're basically spending that stored potential energy that exists due to the imbalance. So you don't have to input any extra energy. The molecules will naturally move down the gradient because there is stored energy within the gradient. Okay. Again, think about it this way. Think about going down the gradient as like going downstream. If you've ever been canoeing on a river, you know that if you want to go downstream, then you could make it a very lazy trip and simply just sit in your boat. You probably want to steer, but even if you don't paddle, you are going to move downstream because the current is going to pull you in that direction. The current is still a release of energy as the water moves and pulls the boat with it. But you, as the canoer, do not have to input any extra energy to go that direction, because that's the natural flow of the water. Solutes will naturally move down their gradient, and they're using that energy that's stored within the gradient. So we don't have to input any extra energy for this movement to happen. Now, here's the thing, okay? We're going to have different kinds of diffusion, and the reason why is because not all substances will easily diffuse across the cell membrane. Some of them are going to have a hard time, and they're going to need assistance to get across. So because of that, there's two kinds of diffusion, passive and facilitated. And the difference here kind of comes down to this question. Can the solutes move directly through the cell membrane on their own? If the answer to that question is yes, then we're going to be talking about passive forms of movement. If the answer is no, then we're going to be moving on to facilitated diffusion. Okay, so the two types really exist because some solutes can get through the membrane without assistance and other ones can't. But it is important to remember that no matter which type we are talking about, none of the types of diffusion require an input of energy. All right, let's look at passive forms of movement of diffusion first. So passive diffusion is going to be when we have a solute that can get through the cell membrane on its own, and it won't need any type of assistance to get across. Okay, so a good example would be dioxygen. It's going to be able to go through the plasma membrane or the cell membrane without assistance. The things that can move across are going to be things that can get across the phospholipid bilayer on their own. So as we talked about in that past video, these are going to be things that are small, no charge to them, things that are non-polar, going to get across by themselves. But what about if we have something that's charged and or too big? The too big, depending on how big. So if it's really big, so think like macromolecule, like a protein, something that's pretty large. If it's really big, then we're not going to be able to use diffusion at all. We're going to talk about another mechanism of movement later on called bulk transport. And that's going to be what would help move something that's really, really large, okay? But if we have something's charged and or just a bit too big to get through the membrane on its own, so something charged or something, I guess we'll say medium-sized, then we're going to use facilitated diffusion to get the materials across. Facilitated diffusion is going to use the assistance of either a channel protein or a carrier protein to move the substance still from high to low concentration. So in this picture, we can see that the sodium ions are in a high concentration on this side of the picture. So there's a higher concentration here. There's a lower concentration here of sodium. And so knowing that, think to yourself for a second, what direction would the sodium go? Diffusion is always from high to low. So we would expect the sodium would flow this direction, okay? Let's look at the potassium, which is these little Ks. Think for a second to yourself where the potassium is going to go. We can see that the concentration is high here, and the concentration is lower here. Since diffusion goes from high to low, then we would expect it to move this direction. All right, another little quick test for you, okay? We talked about carrier and channel proteins in a previous module. So which one of these is a channel and which is a carrier? Okay, answer time. The channel is kind of like a tunnel that is open on both sides the whole time. The carrier is more of like the revolving door that's only open on one side at a time and then changes shape to spit the thing out on the other side. Okay, so facilitated diffusion still doesn't need an input of energy, still going from high to low concentration, but we need the assistance of some type of transport protein because the thing is either a little bit too big to get through on its own, or it has some type of charge or partial charge that it needs assistance. All right, that's going to cover it for diffusion. Pick up with us next time for osmosis.